Okay, g'day all and welcome to another assembly video. So today I wanted to go through some control structures, just have a bit of a look at some basic control structures in C++ and how they translate to assembly. Okay, so we've got 4 control structures to look at today. I'm going to look at if statements, a couple of loops, that's the while loop and the do while, and then we'll finish up with for loops. So the first thing that we'll look at is if statements. So if we've got something like int a equals 5 and int b equals 7, and we want to say, I don't know, int c equals 0. If we have an if statement, like if a is less than b, c equals 1, something like that would be just a basic if statement in C++. So if you want to do this in assembly, the simplest way, or probably the most natural conversion, is to use a comparison. So here's my assembly code over here. So we might use EAX and EBX. I better push EBX first, and we'll pop him at the end. That's just because EBX is not Scratch. Okay, so if we start out with MOVxx5, MOVxx7, then we perform our comparison, which is comp EAX and EBX. Actually, I should MOVxx0 as well. Comp means compare one value to another, or compare registers in this instance. So what we're saying here is compare 5 to 7. That's the values in EAX and EBX. And what we want to say is JAL, EAX is less. Otherwise, something like jump finished, I guess. Okay, so JL means jump if it's less. So if this comparison here, this first operand is less than the second, then we're saying jump to this label just here, EAX less. So we might put that down here, EAX less. And what we wanted to do is MOVxx1. And after that, we need our finished label. Yeah, something like that. Okay, so these lines just here are pretty much a word-for-word version of the exact same if statement from the C++ code. Hold on a second, we've got a bit of an error here somewhere. Jump finished, whoops. Okay, you don't need the colon on the end of your label when you're doing the jump. Nice one. All right, so here we go. Let's have a bit of a step through. All right, so EAX is 5, EBX gets 7, ECX gets 0. I might just add a watch to ECX. There it is there, 0. If we step through again to the comparison, it doesn't actually do anything. The comp instruction just sets up the flags. And then once we perform the JL, you'll see that the CPU actually took the branch. It means that the first operand was less than the second, or 5 is less than 7 in this instance. And now it's going to execute this little line just here, which is MOVxx1. Yeah, there you go. So if we have another bunch of values, say we have something like 12 in EAX, 12 is not less than 7, so the jump won't be taken in this instance. And if we just hit a bit of a play and we step through, all right, we get the comparison, but the JL was not taken. Yeah, so the CPU just fell down here to this unconditional jump, which will jump straight to finished. And ECX, as you can see, still has 0 in it. So that's pretty much exactly the same execution as this little if statement just here in C++. Now, what I want to say with if statements, it's very costly to jump around like this. Using these conditional jumps is very costly because the CPU will often try to execute ahead of time the path that it believes it's going to take. But until it comes to that path, it doesn't really know. And if it gets it wrong, if it accidentally loads a whole bunch of code that it's not actually going to execute, then it's actually got to flush its code buffer and reload the real instructions that it needs to execute. So jumping, particularly conditional jumps, can be very, very costly. And often what you'll want to do is what's called a conditional move. Sorry, completely blanked out there. So for a conditional move, what we might do is mov into EDX, the value that we might want to move into ECX on the condition. And instead of JL to some label, we can get rid of all of that. And we can swap that for CMOVL, ECX, EDX. So this means conditionally move the second operand into the first if the result of the comparison was less. Yeah, so this is going to do exactly the same thing as all of that jumping around before, except we've removed the actual branching. So that's generally going to be a lot quicker for the CPU to execute. All right, so let's just hit run, and what we should see from this is 0 still. Yeah, so after we execute that conditional move just there, because EAX is not less, 12 is not less than 7, it didn't perform the MOV of EDX into ECX, and ECX remained as 0. If I just hit stop and we change this back to 5 in our EAX register, and we run again, there you go. So you can see right then, because 5 is less than 7, conditionally moving on the less condition resulted in the value in EDX, this 1 just here, being moved into ECX. Yeah, so conditional moves were kind of put into the CPU to avoid all of the problems that come about, the performance issues that come about with branching. Okay, so if we just get rid of that for a second. So the other thing that you can do with conditional moves is slightly more complicated statements. So when you've got something that's a compound condition, if we say something like, if A is less than B, maybe and A equals 10 or something like that. I don't know. It's just an example. So here we've got what's called a compound condition. It's a condition that's itself is made up of multiple statements. So A is less than B and A double equals 10. This could be an or just here, and we could have brackets, and we could have more of these things, and B is less than whatever, etc., etc. So you can build compound statements. Now, you can model the same thing using the comparisons and the conditional jumps that we did initially, but things get complicated. You sort of end up with this spaghetti code where you've got all of these conditional jumps jumping to all of these little labels, and it's very, very difficult to read and follow. So a really good way to handle something like these compound statements just here is the conditional moves. And what you do is you compute the result of one statement in one register using a conditional move, then you compute the result of the other statement in some other register, and then you literally AND the results together. I might just copy this whole thing so that I can see what I'm doing. Okay, so we'll make them all comments. Okay, so for a start, MOVxx 5, MOVxx 7, MOVxx 0. So ECX is going to be the result of both conditions. When we're done, it's going to be the result of both conditions. Now, because we've got two statements just here, we're going to need another register, and you could do all of this stuff in RAM too. Yeah, so I'm just using registers because they're convenient in assembly. Okay, so I might mov into R8D0 as well. So R8D is going to be our second statement. It's going to be the result of this equals just here. And then because the CMOV, the conditional moves, actually only take registers as operands, we do need to set the value that we want to CMOV in some other register. So I'll say EDX1. Otherwise, you could just go CMOV equals and then ECX and 1. That would be convenient, but there's no instruction that does that. Okay, so what I'm going to do, compare EAX to EBX, CMOV L, ECX, and EDX. So this is move 1 into ECX if A is less than B. CMOV equal R8D, EDX. This is move 1 into R8D. If A equals 10, wait a minute, we do have to do another comparison. Sorry. I forgot that the second statement here is not actually the same comparison. But then the statement in the middle is AND. So what we can do is just say something like AND ECX R8D, and it's done. Yeah, it's done. So because we've just got two conditions here and we've checked them one after another, we've saved this condition just here with a CMOV to ECX, and we've saved this one to R8D, then we can just AND those two results together and we'll end up with a C equals 1 just here. Yeah, let's have a bit of a run through. So, okay, so in this first instance, the result in ECX should be 0. If we just run through, and we have a bit of a watch on R8D. Okay, so at the moment, just before we perform this AND, which is the kind of compound bit, it's the joining together of the two statements. Just before we perform that AND, what you can see is that ECX has true or 1, and R8D has 0. So what that means is that the first part, this A is less than B, is true, since 5 is less than 7, but A does not equal 10. Yeah, so the second part there, the R8D, is 0. If we step over the next line, you'll see that our result, the compound result of both expressions, is 0 or false. Okay, so if we do change this to 10, and we change this one to 70 or something like that, now that we've got 10 in EAX and 70 in EBX, both of these statements are true. A is less than B, and A also equals 10. So if we hit a bit of a run and we see what happens. Okay, so just before the AND, we've figured out in ECX the result of the first little expression. A is less than B. Yep, it's a 1. And in R8D, we've figured out the result of A double equals 10. And we're saying 1 for that too. Yes, it does double equal 10. Okay, so if we step over the next line, 1 and 1 gives you 1. So the final result there in ECX was 1. Yeah, so I hope that makes a bit of sense. You can just do spaghetti code and lots of conditional jumps if you want, but your program will tend to move a little slower and I would say be very difficult to debug. So another really good idea is conditional moves. I will say that this is really only scratching the surface, and when you get right down to it, saving results on conditions is a fine and very, very deep art form. This is a good start though. Okay, so the next thing that I want to look at is the while loop. So maybe we've got something like while I is less than 100, I guess. I plus plus int I equals 0. Okay, so this is just a little while loop here in C++. So a couple of things about the while loop. For one thing, it checks the condition first. So what's going to happen when the computer comes down here to while I is less than 100, the first thing it's going to do is it's going to check that condition. If that condition is false initially, then it won't run the loop at all. So if we just save that and we come over to assembly, the only thing in the body of this particular while loop is I++. I'll get rid of this code that we had from before. Okay, so this is a while loop, and we might say loop head just here. And mov, I guess EAX we'll use. EAX is I, the little counter that we're using just there. And the first thing that we want to do is we want to check if we can even go into the loop. So what I might do is make underneath the loop, I'll make another label called finished. And what we might do is comp EAX and 100. I think that was the value. Yep, 100. So JGE, jump if it's greater or equal to 100 to finished. Okay, so that's the comparison there to check if we've even got to start the loop. And inside the body of the loop, the only thing we've got is inc EAX or EAX++, in other words. And then we want to do compare EAX and 100 and jump if it's less to loop head. Yeah, there you go. That's a while loop. Good stuff. I might just change this down to something else. We'll make it 5, shall we? 5. Yeah, so when I'm debugging, I don't want to just go through it 100 times. It's going to take too long. So let's have a bit of a look at this. And we'll run it. And I'll just grab EAX and set a bit of a watch on that bad boy. What's he got here? He's got 1 at the moment. That's completely irrelevant from some other function. All right, so he's checked EAX and made sure that he's actually got to enter the while loop. It's decided that it has, since 0 is less than 5. Inc EAX, check the condition. Inc EAX, check the condition. Inc EAX, check the condition. Inc and the condition. Finally, when EAX actually equals 5, this condition fails. EAX is no longer less than 5, so the JL just here, jump to the loop head, is not taken, and the program falls down here to the finished label. So the only other thing that we've got to check is we've got to check that if our value is 5 or if it's greater than 5, we don't actually want to enter the loop at all. So this is an important difference between a while loop and a do while. Okay, EAX is 54 or 36 in hex. Cheers, Visual Studio. Good counting, bruss. All right, there you go. Okay, so the value of 54 didn't pass this initial condition. The CPU just jumped straight down to the finished label, skipping the entire loop. Okay, so that's the body of the while loop just there. You could put whatever you want in here. Body of the while loop. All right, so very closely related to the while loop is the do while loop. So I might just do this do. We'll make the same condition, I think. While I is less than 5, was it? Something like that. Okay, so that's a do while loop in C++. This is the body of the loop just here, and the condition comes at the end of the loop. So the only difference between a while loop and a do while loop is that the loop body will always be executed at least once. Okay, that's a do while loop in C++. In assembly, it's super easy if we've just written ourselves a while loop. All you've got to do is get rid of the initial check. Yeah, so that's a do while loop just there. Body of the do while loop. Yeah, but exactly the same thing. So if we move into here some other value, I'll put 0 back in there. We can have a bit of a look at our do while loop executing. Although I will say it's not very exciting after we've seen a while loop. Ink. It's 5. Get out of here. Yeah, so it jumps down here to rat to run off and do something else. Do some other of its business. Yeah, so the only real difference between a while loop and a do while loop is that the while loop has an initial check at the top. So it's interesting, but in assembly, you've got a couple of options. So in assembly for a while loop, your initial check can actually be different to your final check, which is kind of interesting. Yeah, okay, so that's a do while loop. And I think before we go on, what I might do is just show the regular assembly loop. So usually in ASM, you don't tend to use anything that's normal in C++. You do something similar to a do while loop, but you generally count backwards to 0. So this is the normal, or maybe the most common assembly loop. You would do something like MOVxx 5 and loop head, decxx. Oops, and jump not 0 to loop head. Okay, so that's possibly the most common assembly loop just there, and the reason that it's so common is because it's so simple. I mean, there's only a few instructions just here. So there are some slightly awkward things that come about because of this. Your counter is counting backwards, and often when you're indexing arrays, you'll want to count up through the elements in your array. So if we had something like MOVxx, some array pointer, what you end up doing is something like having another counter. So you would have, say we wanted to add 1 to each of the elements in the array. We could do add ptr rax and 1. So that's going to increment the value in rax. But you do something like plus rdx. Yeah, so it's kind of a little bit awkward, but you have this loop, this outer loop, which is counting the number of iterations or elements in the array. And then you have this pointer, which is the combination of rax and rdx, kind of counting upwards in 4s, which is the size of a D word. Anyway, we can talk about accessing elements in arrays later, but that's the most common assembly loop just there. That really simple, just decxx and jump not 0 to your loop head. All right, but let's talk about a for loop. So for int I equals 0, well, I is less than 10, I plus plus. Okay, so that is a for loop. Let's see how we can make exactly the same thing in ASM. MOVxx 0. So this is for int I equals 0. And the first thing that we got to do is check the condition. So the condition here is I is less than 10. So we'll compare EAX to 10, and we'll jump if it's greater or equal to finished. I'll put that down here, finished. Otherwise, we'll have our loop head, and we'll inc EAX, comp EAX and 10, jump if it's less, I say, to loop head. Yeah, so you can sort of see all of the parts just here. For one thing, the MOVxx 0 is this first little part just here, int I equals 0. The next thing that has to happen in a for loop is the condition is checked. So I is less than 10. That's this condition just here. Compare EAX to 10. Jump if it's greater or equal to finished. You will notice that often in assembly, you'll kind of switch things around. So instead of saying, is EAX less than 10? What we want to do is skip the body of the loop if it's greater or equal to 10. Yeah, you do have to get used to switching around your logic a little bit. It's kind of awkward, but you get there. Anyway, the initial condition check is just there. And then we fall down here to our loop. And our loop contains, well, this would be the body of the loop just here. Contains inc.eax, which is this statement just here. Note that that's got to come after the body of your loop if you're doing a regular for loop. And finally, we finish up with compare EAX to 10 and jump if it's less to the loop head, which is, once again, this comparison just here. So that is a for loop in assembly. Yeah, something like that. You'll notice that it's actually exactly the same as a while loop, which makes sense, really. So yeah, if you read out a for loop, what you're really saying is while I is less than 10, I plus plus. Yeah, it's pretty much all it is. Anyway, that's just a little bit about basic control structures in assembly language. What I would recommend is if you're programming if statements and a lot of branching, really try to use the CMOVs. The other thing that you might want to do is quite challenging is use the conditional instructions in the SIMD instruction sets, your SSE and MMX instruction sets. Sorry, MMX is being phased out. SSE and AVX. Yeah, that'll give you a lot of speed, just a lot of speed. That's pretty much all that I wanted to say. Okay, well, thank you very much for watching. I've got a little merch store down below. If you want to get yourself official What's a Creel t-shirt or something, you have a bit of a look below. You can go over and say hello on Facebook, or you can say hello on Patreon. And other than that, I just want you to have a really good day. And thank you very much for watching.